Good morning. Welcome to the Dallas Independent School District STEM Environmental Education Center for our virtual field trip. With special welcome to Skyline High School. And we hope you enjoy, and we also hope you learn. If you have not registered and you're watching this, if you go to www.tiny.cc/EEC register, you can sign up for it, and that way we can keep a record of whoever attended the programs. This morning, we're going to do a virtual field trip where students will investigate a local aquatic environment. Students will collect baseline quantitative data, including pH, temperature, turbidity, and dissolved oxygen from an aquatic environment. And if you have any questions, excuse me, go to www.tiny.cc/EEC-question and send it in. We cannot see you, so don't raise your hand. Send your questions in. We'll do our best to answer them, get back to you.
Good morning, students. My name is Mr. Monroe, and my part of your virtual field trip today, while you're studying a fresh body of water that we refer to as being lintic, is to take a pH reading. Now, when we're talking about pH, we're talking about measuring how acidity the solution may be, or how base or alkaline it might be. Today, I'm going to be using a Lamont testing kit, which is a very simple kit to use. A lot of people use these if they have large aquariums or aquariums in their house because they want that pH balance to be just right. So I'm going to give you my hypothesis about the lake today. And my guess is this, that when we take our reading, I'm anticipating that it's going to be somewhere around 8. So I'm going to go ahead and take a sample and then come back in, and we will take a test using this Lamont testing kit, and we'll see what it reads. Sample. And since we're doing this out in the field, I didn't use the other type of container that I use. I used a container that has a little spout because we're going to have to measure the amount of the sample water that we're using. In the kit, and we're going to run 2 tests because we want to make sure that it's accurate. In the kit, there are 2 test tubes. And each test tube has a little cap. So there's a line that actually measures out 20 milliliters. I'm going to squirt enough of our sample to the 20 milliliter line. I'm just going to cap that temporarily and set that one down. And I'm going to do the same with this other tube. 20 milliliters is what we're looking for. All right. I'm going to put a cap on that so we don't lose our sample. The good thing about it, this is an easy test to run because I'm going to use a reader here. And there are prescribed measurements that are already color coded along this reader. The next step is to add a reagent called wide range indicator. And once we add that, we should see a color change. The magic number is 10 drops. So I'm going to drop 10 drops of this reagent. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, I'm going to put the cap into the tube and I'm going to invert it several times. Ooh. I can see that there's a color change. Man, here's it going to be a color change. Wow, that's really dark. And I'm going to insert it into the reading machine or reading mechanism. Oh man. Okay. It's off the scale. I'm thinking somewhere between 8.5 and 9. Let's do the other one. See if we come close to that same reading. What's the magic number? 10. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, going to recap the chemical, the reagent. Always do that to avoid any kind of spills. Put the cap in. Invert it several times to mix it. Wow, same color. Wow. So definitely our reading is on the alkaline side. Woo! And I can tell you guys, listen, we haven't had any rainfall or precipitation lately. And there's a tendency whenever we get rainfall or precipitation, it will kind of neutralize and help balance the water that's in this body of water. For example, we know that carbon dioxide exists in our atmosphere. And as precipitation falls, whether you know it or not, when water mixes with carbon dioxide, it changes the water into a weak carbonic acid, very weak. But it will have an effect on water that's in a lentic body of water. So we really need just a little bit of rainfall to kind of neutralize and bring this back into a good reading. And that's all I have for you today. So I'm going to pass it on to the next teacher, and she's going to do a test.
Mr. Monroe, and that was me doing my part of your virtual field trip today with us, doing a test for pH. And I will tell you this, pH is a very important test to run on some substances, especially fresh water. Now, there's probably the most common water quality test that is performed, simply because it can be used as an indicator letting you know that something is chemically changing in that water. Now, the scale that we use for pH testing runs from a score of 0 to 14. Now, the color that I had observed from the test that we ran at the Hidden Lake kind of disturbed me, so I did a little further investigation. And I found out that the reagent, the chemical that I was using to run those tests, guess what? They were outdated. I did use a most frequently reagent that wasn't outdated, and it did come out with a reading of 8.5. Okay? Now, 0 to 14. Anything below 7.0 that is considered to be acidic. Anything above 7.0 is on the basic side or the alkaline side. Now, that 8.5 reading that we got, that's somewhere around in this area right here. Now, if it had tested at 0, boy, that's really acidic. That's like battery acid. And you know that if you spill battery acid on a pair of jeans, it'll eat a hole right in the jeans. Could fish live in that kind of water? No. Up around 3.0, it's like vinegar. Up around 4.0, between 4.0 and 4.0 and 5, it's like orange juice. And somewhere between 5.0 and 6, that's basically what we get as far as rainwater. Now, you heard me say that what contributes to the acidity of our fresh bodies of water, lentic bodies of water, is rainfall. It kind of helps it out. Well, usually rainfall comes in somewhere around 5.0 to 5.5. And the reason for that is the carbon dioxide mixing with the rainwater. And then it can even get lower because of sulfur dioxide and nitrogen oxides that are released into the air, especially from power plants and from automobile exhaust. So acid rain is a real thing. It can be harmful, and then if it's not so acid, it can be kind of helpful with fresh bodies of water that we call lentic. Because I'm here to tell you, if we get a little bit of rainfall, well, not a little bit, we need quite a bit up here. And I don't know whether you observed it around the edge of the pond where the water had kind of receded. That lake was really higher than that 2 weeks ago. And if we get some rain to bring that water level back up and we run another pH test, you know what? Most likely, my hypothesis is going to be this, that it's going to fall within the neutral range. Now, pH is the measurement of acidity of a substance. Hydrogen ions have a big control of that, okay? If there are a lot of hydrogen ions in the solution, then it's going to test acidic. If it's a lesser amount, it's going to be an alkaline or a base. So again, 0 to 14, and it does indicate that there's some type of change. Now, before the ponds behind the center went dry, had we taken a reading out there, and I know that when we've had rain for a very long time, and I've been out here working in the summer, our ponds behind the center have tested as high as 10.0, which that's not good for aquatic life. Fish and other aquatic life usually need a range somewhere between 6.5 and 8.2 on the scale. Now, I will tell you this also. If you get a reading somewhere around 4.2, guess what's going to happen? All your fish are going to die. Now, there are a lot of people that test their aquariums for pH because, again, that is an indicator that, you know, if it doesn't test neutral or test close to where fish and aquatic life can live in it, guess what? It indicates that something needs to change before all that life dies and ceases to be. Hopefully, your time with me and what you saw on the video has helped you to kind of understand that pH and why it is the most common water quality test performed. Now, I'm going to give it back to Mr. Gorman, and if any of you have any questions, that he may be able to answer those for you. So hopefully you'll have a good rest of the day with us. And Mr. Gorman, I'm turning it back over to you.
We're here at the beautiful lake, and my name's Nash, and I'm going to be taking some temperature readings of the water. So the air temperature that we just took was 24 centigrade, and we're going to be taking first a couple different measurements, close in and far out. Now we talked about dissolved oxygen, so the water temperature will also vary depending on the depth of the water. And it's important because lots of different organisms can't survive if it gets too hot. Not just because they don't have oxygen, but just the temperature. So water has a lot of thermal inertia. That means that once it gets cold or hot, it changes slowly. And if you've been at the pool this summer, hopefully, you've noticed that down deep in the pool it's cold, and up at the very top surface it's warm. So just like air, hot air rises, cold air falls. Same thing with the water. The cold air will fall, sink to the bottom of the pond. I don't think I can get out that to the middle of the pond unless I had a little boat, but I'll go out as far as I can without falling in. So let's see what it is right here at the shore. Give it a little moment here. Do you think that's long enough?
Yeah.
Right here. It is the same as the air temperature. Surprise, surprise. Okay, now here we go. To keep from falling in. It's about a meter deep, I guess, out here. Right here, and I'm going to throw it out farther. About a meter deep here. I can tell it's colder here, so now it's like 20, 23. So it feels cold on me. Okay. Move out a little bit farther and then throw it out as far as I can. Out here in the deepest part, 22.
Well, hello. Back in the dry classroom here. And the importance of temperature is that some things like it hot, some like it cold. Okay? And nobody likes it too hot or, in any case, too cold. The important thing about water is that it has what we call a high heat capacity. That means it takes a lot of energy to heat it up. That's why we use it to cool our radiator, etc. Once it gets hot, it's going to stay warm. And once it gets cold, it'll stay cold. It has what we call thermal inertia. I mean, it takes a lot of energy to change it from hot to cold or cold to hot. And temperature is important for all the living things out there. You saw in the video that the water lake was quite warm, really, based on the air temperature of that day. It's been warm all summer. There's a small temperature gradient. That means it changes slightly as we got out in the deeper part. Our native fish are adapted to the warm water. they don't die when it gets too warm. But of course, there's that relationship between oxygen and temperature. As the water gets hotter, it is able to hold less oxygen, and the fish need that. So our little ponds over here on this side dried up completely this summer. And the last survivors, okay, were these carp. They not only can deal with the heat of that water is evaporated, but they can deal with very low oxygen environments. That's why I have a little cousin of a carp that I can keep in a jar. And a little goldfish, they're kind of little domestic carp. And most other fish have to have an aerator in their aquarium. But the little goldfish can come up to the top for a little bit of air. So they're very hardy. They're not naked. They're pretty tough. Now, warm water also encourages the growth of microorganisms like algae blooms, and some can be really dangerous, like the brain-eating amoeba. Okay. The eutrophic condition, the low oxygen condition can be very hard on the fish. Okay. So the surface water is really warm, and doesn't have any oxygen. The bottom is cold and just too cold down to the bottom sometimes. So, because I made a little chart here of the relationship between, sorry, finger in the wrong place. An inverse relationship between temperature and dissolved oxygen. So as the temperature goes up, the dissolved oxygen goes down. And also an important thing is that land surface heats up a lot quicker than the water. And this is important for us and everybody who lives around the water. And I did a little experiment demonstration, and I took a big 5-gallon bucket of water and I stuck it in the refrigerator along with a thermometer on the shelf. And then this morning I went and took it out and I took the temperature. And I've been taking the temperature of the table and the water all day. And what I discovered is that this one has heated up to the room temperature really quickly. I mean, almost immediately. That's what you see right here. So that line went way up. The water, however, has maintained its temperature. Okay. It's gone up a little bit, but much more slowly. So this demonstrates that really important property of water in that it moderates the temperature around it. And animals like my friend the turtles use that to their advantage. So they'll be in the water. If the water is cool, they'll come up on the log and warm up on the log. And then if they get too hot, they can go back in the water and be nice and cool. When it gets too cold, okay, the water's going to stay warm and they can be in that warmer water. So animals use that property of water to their own advantage. So thank you, and I'm going to give it back to Mr. Gorman for any questions.
Good morning, boys and girls. My name is Mrs. Fuller, and I'm going to talk to you about turbidity and how to measure turbidity in a freshwater lake. This is a turbidity tube. In order for us to have water that's clean enough to treat, in order to drink, the turbidity has to be equal to or greater than 85 centimeters. So we're going to fill this and see what the turbidity is of this lake. Now, this symbol is called a Secchi disc. It was invented by a Catholic priest by the name of Angelo Secchi, and it was invented to measure the cleanliness or clearness of ocean water for the Vatican Navy. At one time, the Vatican had a navy. Now we use this one. It's modified from his. It's 2 black pie pieces and 2 white pie pieces. And when the person looking down into the turbidity tube can see this symbol, that we know that that's the clearness of the water. So I'm going to go make a collection now.
Okay, Mr. Monroe is going to peer down into this. When he sees the Secchi disc down in the bottom of the tube, he's going to tell me to stop the flow of water. This water is full of all kinds of things. It's got silt, it's got clay particles, it's got algae, it's got living organisms, all kinds of things. So we're going to see how clear this is. Okay, there you go.
Okay, right there.
All right, let's see what we have. What do you read?
It's pretty close to 10 centimeters.
All right. So instead of having 85 centimeters of clear water, we've got 10. This water would be disastrous if you were to drink it. It would make you terribly sick. It would give you weeks and weeks of diarrhea, if not kill you from dehydration. This water is not safe to drink. And in order to clean it, to get this stuff out, we would have to put some flocculants in it and stir it and get that stuff out, and then it'd have to be treated for microbes so you wouldn't get Giardia and things like that. So this is turbidity, this is a turbidity tube, and the symbol at the bottom is the Secchi disc. Thanks so much. Have a lovely day.
I'm Mrs. Fuller, and what we were testing was turbidity, and turbidity is simply the test of the cleanliness or clearness of water. What we were looking at were TSS, total suspended solids. Of course, the more suspended solids there that you have in the water, the higher the turbidity. The turbidity affects the light intensity in the water column, which in turn affects the rate of photosynthesis and the distribution of organisms in the water. Now, lowered rates of photosynthesis is going to affect the level of dissolved oxygen in the water, which in turn will affect the fish. Higher turbidity, higher levels of TSS absorbs heat. Now, you just saw that in the segment with Ms. Nash about the water heating up. Well, it can increase the water temperature, and that in turn lowers the dissolved oxygen, the DO. Higher turbidity can also be an indication of a pH that is more alkaline. So all of these things are of a piece. I talked to you in the video a little bit about the Secchi disc. I wanted you to see how it was spelled. It's an Italian name. He actually was an astronomer, but he's the guy who invented it. I'm going to show you. You weren't able to see it in the video, but this is the turbidity tube. You can see the Secchi disc way down in there. Can you see that? Okay, that Secchi disc is what Mr. Monroe was looking for as the water drained out of the turbidity tube. So you want water that's clear, not highly turbid because of lowered oxygen, higher pH, and also all those microbes and biota that's suspended in there. So turbidity really gives you a pretty good idea of how healthy lentic water
Ms. Ramirez, and in this segment, we're going to be learning about dissolved oxygen. We're going to watch a little video first, but just so that you know, dissolved oxygen is simply a measure of the amount of oxygen that is in a body of water. So just like you and me need oxygen to breathe, so do our aquatic organisms as well. So I'm going to go ahead and present my screen. We're going to show you guys a quick little video of our testing out at our hidden lake that is in the Post Oak Preserve. In this segment, we're going to be measuring the amount of dissolved oxygen, or DO, that is in the lake here. So we're going to be using a water sampling body. I'm going to go into the lake. I'm going to drop it down. It's going to set based on this weight. I'm going to collect a sample of water, and then I'm going to come back to shore and use our dissolved oxygen testing kit to find out the amount of dissolved oxygen that's available in our lake. And just like you and me need oxygen to breathe, so do our animals and aquatic plants as well. So that's why oxygen is very important to the aquatic organisms too. I'm going to be walking really slow into the water. There's a lot of debris, bricks. We come across old tires, shopping carts. So I'm usually walk pretty slow inside so I don't trip. That was a rock I just hit. So you'll notice I'm going rather slowly to avoid any pitfalls. Okay, so I'm going to take my sampling bottle and I'm going to go ahead and drop it in the water. I know you probably can't see this, but there are lots of bubbles forming around the sampling bottle. While we're waiting for this to fill, this pot is an example of a lentic system. So lentic bodies of water are not flowing, they're kind of stagnant. When we talk about lotic bodies of water, we're talking about running water, things like streams. So typically lentic bodies and lotic bodies will have different amounts of dissolved oxygen. I'm going to go ahead and try and pull it up and see if we got our collection. And we did. As I'm walking back, that was my first time using that sampling tube. If you do have an opportunity to use one, you don't actually have to leave it in the water that long. So that was my first experience with that tool. Okay. So this little tool here simply just gathered us a sample, but now I have to actually test it using a test kit. So I'm going to remove our sample. This is a Chem-Met dissolved oxygen test kit. And I'm probably going to sit down for this just because it's a little bit easier for me to use it. I'm going to pour about 30 milliliters of our water sample into this little beaker. I'm going to take one of these glass ampules. There's a chemical inside that reacts to oxygen. I'm just going to put the ampule inside the beaker and I'm going to take my thumb and I'm just going to press down on it. My goal is to break the ampule tip. That way some of our water sample will be injected into the ampule itself. That's usually the favorite part of students that come out here. They just want to break something. So that's an easy way to get the test. Hopefully you were able to notice that there's a color change. I'm just gonna, you notice that the water level rose because our sample has been absorbed into the ampule. I'm just gonna take it out and invert it a few times just to make it well mixed. There's a bubble inside. We just wanna make sure that that bubble has a chance to go back and forth a few times to accurately mix the sample. So remember, our ampule looked like this before. It had that kind of like yellowish liquid inside, and now we can see it's kind of turned like a blue color. The way the test kit works, there's a set of known dissolved oxygen samples here. So all we have to do is just take our ampule and match it with one of these ampules. So let's compare these. So we kind of just start out comparing it to the different color samples. My sample is a little bit darker than these. I'm gonna call it at around maybe 8 or 9. So the way this is read, it's parts per million. So for our dissolved oxygen, I'm gonna say it's probably around 9 parts per million for the dissolved oxygen sample. And what that tells us is that's actually pretty good. So for our dissolved oxygen, we typically want it to be 6 or above for the amount of DO in an aquatic system. Anything between 1 and 4, that's pretty low. So that means there's not a lot of oxygen in an aquatic environment if you're in the low numbers. And if there's not a lot of oxygen, you're not going to have a lot of living aquatic organisms. So dissolved oxygen is very helpful in determining the quality of a water system. So that's dissolved oxygen. Now our dissolved oxygen can actually change based on temperature. So typically the colder it is, the more oxygen a water body can hold. And the hotter it is, the less dissolved oxygen that a water body can hold. So temperature also plays a role in dissolved oxygen too. And that's all I have for dissolved oxygen. I'm gonna go ahead and stop the video. While I'm sharing my screen, I did wanna show you guys the test that we used was a dissolved oxygen kit that used a sampling of different colors to help us measure it. If you actually have the money, there's some really fancy probes that you see here. These are digital probes, and all you do with these, you just stick the probe into your body of water and it gives you an actual numerical value. These probes are typically going to be more accurate than the testing method we chose, and that's just because the testing method we chose utilized that coloring system. So the ampules, inside these ampules is a liquid called indigo carmine, and that indigo carmine, when it comes in contact with oxygen, it oxidizes and turns the liquid blue. Well, when we do our testing, it's kind of like subjective testing because we're doing a color match. So sometimes what I might think might be a 10 level blue, someone else might think it might be 11 or 12. So it kind of just depends on what kind of testing apparatus you're going to be using. Now the waters that we tested are a little bit different than some of the water systems that we have behind our building. So I'm going to show you some images of a pond that we used to have behind our building. And as you can see here in this picture, this was a pond that we had, and you can see that it has nice, clear water. There was a lot of fish living in this pond system, a lot of carp and catfish. And then you can see these white birds, the ibises, enjoying a nice feast while they were fishing for food. Slowly over time, that pond became very eutrophic. And eutrophic is just when we have an oxygen deficiency in a body of water, and it causes that body of water to essentially die. So a lot of the organisms that were in this pond died off. With those large algae blooms, it depletes the amount of oxygen. And as we know, aquatic organisms need oxygen to survive. So over time, that body of water eventually dried up. And what you see here is kind of our dried, cracked up pond, and then the remains of the fish and skeletons. And then also, Ms. Nash was talking earlier a little bit about temperature and oxygen, and she showed us her lovely goldfish. Our aquatic organisms need oxygen as well to survive. So sometimes in fish tanks, you might see the little aeration systems with the filters and the bubbles. Those bubbles and aeration systems just help to incorporate more oxygen into those tanks, so that our aquatic organisms have oxygen to breathe as well. So those are just some examples of our fish tanks that have those aeration systems or those bubble systems as well. And then I'm gonna stop sharing our screen, and we're just gonna do a really quick review about dissolved oxygen. So we talked about dissolved oxygen as simply being the amount of oxygen that is in a body of water. And again, DO is just short for dissolved oxygen. And it tells us water quality. So depending upon DO levels, depending upon temperature and pH, we're gonna see different living organisms in a body of water. And dissolved oxygen is affected by the movement of water. So typically speaking, fast moving water like our lotic systems, so the flowing systems, think of rivers and streams, those are gonna have more DO. And then slow water, like a pond or a lake, systems that are stagnant are going to have less DO. So the movement of water affects the amount of DO. Also, algae blooms. So we looked at an example of a eutrophic system. So those algae blooms really deplete the amount of oxygen available within an aquatic system. So when we have excessive algae blooms, you're going to see low DO numbers. And then as Ms. Nash kind of talked about earlier, temperature, there's an inverse relationship between temperature and dissolved oxygen. So typically when we have warm water, like during the summertime, we're going to have less DO. And then during the wintertime, cold waters can actually hold more oxygen. So if we have cold water systems, you're typically going to have more dissolved oxygen. So there are different factors that affect the amount of dissolved oxygen in a system. I'm going to give it back to Mr. Gorman, and he's going to close up our presentation.
During this virtual field trip, students investigated a local aquatic environment. Students collected baseline quantitative data, including pH, temperature, turbidity, and dissolved oxygen from an aquatic environment located at the Environmental Education Center. We want to thank you for attending, and we would like to know how we did. www.tiny.cc/EEC feedback. If you would fill that out, we'll use that information to improve our programs. Whether it's good or bad, we would love to hear from you. Thank you.